So, the rest is called this subject, of course. So we have our fifth lecture already. Fifth lecture, and the topic of this fifth lecture is still very much related to what we talked about previously. So I will use this opportunity to maybe repeat some things or recap some things from the previous lecture, and maybe explain something that we treated rather in, or I treated them rather in a hurry, and with respect to that additional example that I provided, I will explain again, or say something about this design here, and then we will talk about use cases and aspects. We already mentioned that already in the first lecture, but there are some more details to be considered, in particular with respect to what you know already about this theme approach. So actually, I think, or you should remember this. This was probably the most complex theme that we had there. So this is an aspect theme, cross-cutting theme, and as I said, themes involve both behavior and structure. And here, this cross-cutting theme defines how we address our alarms, but the theme approach does this, tends to do this on a more general level. So, no actual alarms, nor buildings, nor rooms are mentioned there, although we know that our main object are buildings, part objects are rooms, and operation class is actually our alarm. How do we know that? Well, just move a little bit further this diagram. I made it bigger so that we can. Is it really wrong? It is. That is good. So there's this bind expression there where you can actually see to which element you actually connect those, say, mock elements. These are not real elements. They will not do anything. They will not be put into operation unless we connect them to some existing elements, some elements in our system. And previously there was some mistake. There was some mistake in this bind expression, but the explanation was actually correct. So I overlooked that there were actually some operation class appearing there. Maybe it was because we made our implementation in aspect J to work over rather an operation class that stands for the alarm. So the design in aspect J was trying to get as much as it could close to this design here. But with the use of abstract aspects, but you can't actually do everything like here. So that you would have a dedicated construct that covers really this theme. This is rather covered by that abstract aspect, but as you know, you can't actually write such a general pointer. You can have an abstract pointer, but that pointer does not have its body. It does not have. It's not an actual point guard. There are no real references consequences to anything there, so it's just a name for a point cut, maybe with some arguments and nothing else. So we cannot really make a full or mirror of this design in our ASP.NET code. But one of the things that occurred there was this operation class, and the operation class had to be connected to that alarm class. We'll actually recall a little bit of that design shortly, but what I wanted you to observe here is that in this case, like in a case like this, where we follow this control flow through that part or room class, our point cut would look something like this. So we have one control flow of the building class, and our point cut mentions operation class. Operation class actually is an interface that we enforce upon our alarm class. As you may see here, let me make this bigger by putting down this taskbar. Oh no, I want to set it like this. Just for a moment, I'll turn it off. Now we can recall the code that we had. Not actually this part, but this one. Or actually, yeah. Here in the abstract aspect, we. Aspect, we actually create this interface to stand for operation class that is present in the design that we can see here, and we need to bind it to our alarm class, and we do that in our concrete aspect. Our concrete aspect actually says declare parents alarm implements operation class, and then we are forced, or not forced, but we want actually to use. We are forced by declaring the existence of the point cut operations, and by mentioning here operation class, which is the only way to keep this abstract self-contained. So as with this theme, this is a kind of a self-contained theme. Like it defines making some behavior differently, but it does so internally in terms of the structure that is presented here, and in terms of these parameters that are declared here. Maybe we should have included some mock classes for part and operation class as well, but operation class is actually there, but I'm not sure that this is really important. So what is important is that this cross-cutting theme defines, as I said, all the things that need to be done upon the things that it declares itself. and there's then only then we have this binding, and it may be bound to different contexts. And then these elements will be bound to these formal arguments, to say so. So, because of that, we try to mimic this a little bit in programming by including this abstract pointer. That's the only thing that we can do in AspectJ. We can't go any further because there is no way of declaring the actual point cut. We can just name it and declare its arguments. But what we can do is to remain faithful to that design that we had in theme, at least on the level of arguments. So on the level of arguments, we mention operation class. We don't mention no alarms, no such things, because we don't know about them on the level of this aspect. We want to have full obliviousness to the rest of the design. And I think it's maintained here. So for these purposes, I hope I won't have to restart my computer. So for these purposes, here we have this interface inside of the aspect and not outside of the aspect. So we keep it, although it is accessible, as you know probably in Java, from the outside. But at least we want to say that it is something that we define within the context of this aspect, and it's not intended to be used elsewhere. It is used elsewhere only in if something inherits from this aspect, and here we have this propagation, and only to the extent that we actually say that alarm is our operation class. That's why this point cut of operations mentions, and this is the first version that we have here, and which is mentioned in the slides. The first version that is mentioned here. Maybe it's better to have a look at it here, because it's this environment is kind of small. Now, so we have the full point cut here. So that's why I have this operation class, as I explained there. And what we follow are calls to the operation class turn off method. Yeah, that's down there. But we must go through one control flow and the other control flow. We could do this also this way. A little bit because the important part is missing. We might switch this one control flow to this within code point cut. Consider this. And try those point cuts yourself. Try that example yourself. And you will see that both versions will work. But what's the difference? From the perspective of achieving our intent, with this example, with buildings, with rooms, and with alarms, that's fine. So we have our design is we have building contains rooms, and rooms contain or are equipped with alarms. So for that design, both versions work. But what would be the difference? Difference would be if we would imagine if we change the base design, of the design of the base theme that we are connecting to via this bind expression, so that's security system. So if we change that, then it makes difference whether we use control flow or within code, because within code remains only within one method lexically. Just as you wrote it, lexically means word by word, like as it's written. Control flow is a dynamic thing. Control flow means take take everything, no matter how deep it goes. All the calls from the method that are being called and so on. So that's a huge difference, because if we would extend our design this way, or if we would put some class in between on everything, things might change. And if we would consider shutdown, if you would consider a room to consist of some elements like windows, doors, or whatever, and if we would extend this control flow there, and if we would have our alarms connected to those elements there, then within call will fail. So this is why I'm talking about. This is that this is the way that point cuts fail or break, and we talk about point cut fragility. So some point cuts, or all point cuts, are to some extent fragile, and they might be fragile more or less. Depends on your efforts, how you make them be more resistant to change. So then we had this final design. So this is quite like maybe there are no arguments, so those two dots need not be there. But this is quite general perception. So we go all the way. So wherever in the control flow of this method shut down the building, wherever, no matter how deep we go towards this operation class, which represents alarm, no, doesn't matter whether we would have rooms, windows, whatever, we will reach our alarms there, if that's what we want to do. Yeah, so that's important. So we can make it worse by having more general point cuts. So we will capture some joint points that we do not want to capture. So that's it. So I leave that example with you. So I will not demonstrate it now. So we might get back to that example in the next lab. So try all. There are four versions of the point cut operations. Actually, the first one is the simple one without any control flow. So that's only related to that example, to that case that we have just our alarms and trying to not to switch them all based on whether they are connected to special sensors or not, as you remember maybe. And the three remaining ones are applicable to this case of having this security system include buildings, rooms, and then rooms are equipped with alarms. So try these. They will all work, but you may have a look or try considering them. The third one, I think, let me just see, the control flow. But this one, no, there are two control flows there. But this one, with code, this one with code would work even if you would leave out this control flow pointer. So you may consider even different versions of this, and we may discuss this if you would have any questions regarding these pointers, because you would catch calls to this turn off method within. I'm not doing this. To this turn off method within the code of room shutdown. But if you then if you would have those calls outside of the building shut down, and you wouldn't want to capture those calls, then you will capture also those calls that you don't want to capture. So that's the question of how you construct your point cut, how you limit its effect. Okay, so that's one thing. Any questions regarding this? Comments? Opinions? Are those themes too difficult for you, or are they understandable in the notation? Maybe those bind expressions are strange, but just follow the types. There's many parameters, binding parameters, as there are declared parameters. So you're used to these things. I mean, but the parameters are not the values, but the names of the elements. So that's really different. No questions. Then we have this joint point designation diagrams. We are not going to deal with them very much. I think I explained some things there. And here's an example of a joint point designation diagram that can capture structural configuration. How this can be used is like this. If you mark the captured elements or parts of what you capture by some variables or labels, you can operate with those elements that you captured. And there was a system implemented that worked that was able to query UML models using these queries, and even that there were even other attempts to do this. Doctor, associate professor, even Polashek, some time ago had some student projects regarding the model queries, graphical model queries, and I think that there are other similar projects, but the thing is that I don't know, maybe you know, of any commonly used UML tool to include this, to enable you to make graphical queries to your models. And it doesn't seem to be that useless at all when you take a look at that. So that you would be able to pick up the element, not for the sake of modeling aspects, but for the sake of understanding your model. And with respect to aspects, if you would have this, and if a tool could pick up those elements, you could work with them, but for the sake of modeling aspects, maybe it's enough to imagine that capability. So it's possible. So this is something that can be done, and the elements can be picked up, and you don't need your model to be executable. If you don't need your model to be executable, then it's a question of having a correct notation, and this notation is correct in that sense. So you could use this to model your point cuts. So why I'm talking about this is that some of you would deal with maybe some sophisticated point cuts in your projects, and you might consider expressing them using the joint point designation diagram notation, for example. It's not, it does not require much special knowledge to be comprehensible. And you might better see what is being captured by representing things graphically than using the aspect J notation, for example. So to understand aspect J notation, you must understand those primitive pointers. If you don't know what C flow means, you're lost. What arcs means, you know, we have to go through this, or this, or target, or whatever. You can imagine a bit and guess, but you need to look carefully at that and even try those pointers yourself. For this seems to be, you know, like, if there is a configuration like this, and if you know UML, so this is an object, so you capture all the objects of the class myClass that contain an integer attribute and that contain operations of return any type. So this is quite UML, it should be vice versa, like and I took this example from somewhere, but sometimes it's useless. So you should probably use correct UML notation like this, because the time goes there, and something like this, and a little bit of aspect J. So any arguments, any number of arguments. If you say that if you leave out those two dots, then the convention in aspect J says that you are capturing or looking for methods that have no arguments. So here you have those exposed elements declared. You don't have to mimic this exact notation with these frames or whatever. Just put a UML diagram that captures something. You mark. You may even develop your own marking system to mark the parts that you are capturing, and you just say somewhere, okay, this is the exposed part. And things can get more complicated if you use behavioral diagrams like here. So here we have a sequence diagram. So our security system. This is a kind of an alternative representation of what we had with those alarms. And this element actually is not an official part. What is official? Officially, I don't know whether the theme notation was used to model some practice. In practice, to model, as we said, real software systems. It was used in papers to represent parts of the design, of course, but it's not supported by a dedicated tool. There was some attempt, but the tool is not available actually. So that's a major obstacle, I think. But anyway, if you would search for this element in the theme book, or the book that defines the theme approach, you wouldn't find it. So this is an element that I took from the theme approach, from the JPDD, joint point designation diagrams, and applied it to theme approach. Also, it was used in other querying languages, graphical query languages for UML or other modeling languages. Some kind of interaction. So this is not something that is unknown to us or that is very mysterious. Something that we need. So if we want to say here that we skip any number of levels, we go directly to what's interesting, and what's interesting are the operations turned off upon the objects of alarm class. So this looks pretty much like what we had in theme. It's only that we don't have explicit connections. We have these parameters, or whatever we capture, then we can work with that further. But this approach does not state explicitly how we connect things. And there were attempts. This was a completely wrong point got there. Related to another example that I had there before, so I'll get rid of that for the sake of slight consistency. So here, no, this is just a more complicated example of the same kind that involves both structure and behavior. So you can have both, and there are the joint points that you actually capture. So you go all the way just to capture those specific joint points which are actually close to this search method. And as you see, sometimes you need to say if you want to skip some parts of the control flow, as we talked about in our example, then you have to involve some further specification of your control flow to limit the effect of this expression. There's an attempt to write down this point, but it's not that important now. This is just to say that there's a reference to this paper, I think attached to this lecture, but it's not, again, it's not very important. Just in case if any one of you doesn't seem according to your project topics, but maybe things will change a bit over time. So there are ways of interconnecting JPDDs and theme in terms of using JPDDs to better express these bind statements. And I think that's here. So your bind statement might be expressed more expressively, using JPDDs. I don't want to go into details now. I think that it's just worth mentioning that somebody tried to combine these two approaches and use JPDDs exactly where they are strong to express further not just to express, but to separate that cross-cutting. So here, if you would consider these things, they are to some extent relaxed from what is presented here, complicated behavior captured there, and the part of it is transferred to this bind expression. So that was the goal of that paper. As I said, that's something that I just want to mention briefly, and we're going to deal now with something else, but I don't want to turn this off. So we're going to talk about aspects and use cases now, which is the topic of this lecture. So again, try the example, we can discuss the details of those point cuts or possibilities, options for using different kinds of point cuts in the next one. This is not a terribly interesting or complex diagram. It shows only two use cases, called peer use cases, because they are not subordinate, to say so, to each other. They are peers, like no use case out of these two use cases is to be considered to be above or some higher importance or that rules over another one or whatever. So there are peers. So we have cancel an order, place an order, use case. Customer is not that much important here. This is something that we have actually already discussed, but it was a long time ago. So I will remind you of this way to implement or design these use cases. So here we have formally underpinned those two use cases by collaborations. You do recall collaborations. Are you fine with collaborations? I was explaining recently collaborations again to my students in the software modeling course. I explained them. I explained them once. They had an example, and now they had finally they had to do their own collaborations. And that was the point that they got confused by collaborations. So it means unless you are forced to do something, there's a risk, a great risk that you don't understand it. So are you fine with collaborations? And you can say yes, and we will go on. Yeah. So I'll explain it. Okay, so collaborations are just an element that enables you to hide the behavior. So imagine behind this collaboration a full-blown sequence diagram that involves what? Well, these two elements, these two classes that are associated in this collaboration. So you don't say directly in the collaboration what happens, or you don't name the elements that the collaboration is related to directly inside of it. So it's pretty simple or stupid, and just as a repetition of a use case that it stands for. But formally, it is something different or more general. For example, you could have a collaboration that describes what happens within a design pattern. Design pattern makes things to be performed between or among the roles. For example, if we consider observer, you could have your own class or classes connected to observer. I don't know, give me some example. One of them would be observer, and another one would be, as you know, subject. I omitted those roles there. I could involve, like, this would be a role of the order manager again, or placing order manager or whatever, more specific to this. And this would be a product, but not really a product, not a general product, but the product that is being ordered. So ordered product idea, the corresponding role for this. And here, recall some example.
Some temperature sensor and some display.
Very good. Temperature sensor.
Or something like this.
That's exactly the example that I use in software modeling. So great that you recall that. So temperature sensor goes where?
That's the subject.
Subject. So I would call it T sensor. And it goes.
And that's the display. Observe
Display.
For example.
So if you know what observer is, and that within the observer there is the notification process, and yeah, you know how it goes. So it's hidden here, and the notification process can be defined with respect to these two roles, and whatever you connect to this behavior defined here actually takes over that behavior. So the idea of collaborations is more general than just for use case representation, but actually it's very good to formally underpin use cases by or that say that they are realized by corresponding equally named collaborations. So here we have our collaborations. What is exactly being done? I'm not drawing the sequence diagram at the moment. I don't want to do that. Maybe I don't know how to do that yet. What I know is these two classes are involved. And at the same moment, before I go to the next stage, observe that. But not in the sense of the observer, but observe that the order manager is also here, but we consider here it's cancel order. So it's a model. It's a order canceller, to say so. Order canceller, and here this is order placer or whatever, and that's why I consider only order product method there. For the product we are not quite specific. So we do not consider here, maybe our design is not complete. Okay, so it's some level of detail. And next, for the things to work together in normal object-oriented systems, we must put together these two separate views of order manager into one consistent class. And this is what we call symmetric aspect-oriented modularization for decomposition and composition. So these two views here, so these two collaborations with those partially defined classes are actually aspects. Or I can omit the explanation and say simply that collaborations are aspects. Think of it for a moment. Collaborations are aspects. Yeah? So, to get back to what we had in the theme approach, which is not maybe, I don't know, is it readable? It is. You have a very good site. So here we have this building room alarm structure that I talked about in the previous lecture, and that we recalled a little bit a few minutes ago. And here we have the corresponding behavior. So there's much more in this system. Buildings might have their IDs, might have whatever we need to deal with buildings and to deal with buildings from other perspectives of aspects. But in this aspect, from the point of view, it's too much to say. for the sake of this aspect, we don't need anything else. We are just following the shutdown process, and this aspect is called shut down the system. So despite we call those and this theme has no parameters. It's not the cross-cutting theme. So it might be wrong a little bit to differentiate between or to call cross-cutting themes aspect themes and themes like this base themes. But that's the terminology that is being used in a theme. And the theme approach does not really mention symmetric aspect-oriented modularization. If you would look thoroughly throughout the book, they're not mentioning symmetric aspect-oriented modularization. So the authors were not fully aware of this. So what I want to say is that such themes like this, base themes in the theme approach, are also aspects in the sense of symmetric aspect-oriented modularization. And we compose them. So here we have another theme which has a more elaborated, contains a more elaborated alarm class, and we compose these themes into a greater design. So we don't say explicitly this method advises this method or whatever, or affects this method, or what affects what. But we will need to resolve such things in the binding expression or matching expression. So for now it's just match by name. But if you consider the methods that are repeated, like turn off and here turn off, we might be puzzled what to do with them. Are these two the same? So it doesn't matter which version we include, or is one of them to be executed before the other one, and which one? Or instead, or whatever more complex behavior we may imagine. So again, we will fall into that asymmetric aspect-oriented thinking, and we will perceive one or the other method here as a piece of advice to that other one. Yeah. So in the end, like you have your object-oriented programming. Inside of object-oriented programming, you always have some kind of procedures. So in a way, it is a layer over procedural programming. And in your procedural programming, you are using things that are made up for you not to bother with assembler. And in assembler, it's just a set of mnemonic codes in order to not to cope with zeros and ones in real machine code. So we are just creating additional layers of abstraction in order to cope with things in a more comfortable way to our mindset. So sometimes we must fall to deeper levels and treat them in a technical manner. What's this? Collaborations again. You might not be very happy with the theme approach, so you might use collaborations like this, and they will enable you to abstract from sequence diagrams. Sequence diagrams might be complicated, so we can hide that complexity behind these nice elliptical elements. So shut down the system actually is a collaboration of these three classes or objects of these classes. Actually, you could draw your collaboration even like this to involve, to include the objects it refers to inside of it, so to make it more obvious that it talks about objects. So like this, so shut down the system. Yeah, would involve a building object which is related to the room object or room objects some way. But in this example there's only one. Things are not perfect here now. And that's because UML tries to make us generalize our drawings, generalize our diagrams. When you draw diagrams, we are used to draw example situations. Sequence diagrams. Are you happy with what are called? Combination fragments or combining fragments? Combination.
Combined fragments.
Combined. Combined fragments. Combined. Combined fragments. Combined fragments. I'm happy with that. Loop, opt, and such things. When you put them inside, we even had some there. Yeah, loop. And making all the things. Well, I omitted the arguments and so on. Have you ever drawn a complete sequence diagram that represents completely some method?
Yes, I'm not sure.
Probably yes. Okay. We always tend to omit some things there. Yeah, yeah, because it's too complicated and it's too clumsy to deal with these diagrams in UML tools. I never found an appropriate UML tool to do sequence diagrams easily.
Yes, and probably you lose the readability of the diagram when you...
And the readability. And actually, sequence diagrams were invented to depict example situations, not a general situation. So they were used to, when we consider things, so there's that object and that object, how do they communicate approximately? One situation, another situation, and so on. You have even communication diagrams which depict objects and relationships between them and the messages, how the flow of messages between them. Actually, they enable you to consider several sequences, numbered sequences, 1, 2, 3, whatever, in one diagram, so that you can see different behavior configurations. And these are all examples, not a general communication or situation with communication. So that's why we postpone these things mostly to programming. These collaborations enable us to abstract from sequence diagrams and say what collaborates there. Anyway, and now actually we can see that the situation is the same. So actually our themes, even base themes, are aspects, collaborations are aspects, or aspects are collaborations of roles. Maybe may put it wrong because that I didn't include the role names there. They are important because that's how we see the purpose of our aspect. Maybe you would be worried about having use cases like alarms or shutdown system or whatever, or my shutdown system might sound like a user level use case, but sometimes we consider use cases not just specifically related to user goals. So those are most characteristic use cases. These are actually such elements like this that are floating on this sea level. That's a metaphor used by Alistair Cockburn to deal with the range of use cases that we can use that we need to deal with. Mostly we deal with these that are floating on the surface that we can observe as user goal level use cases. But some things, we are not too much worried about those guys that are flying in the skies. Used to have more bigger picture of the system. But we talk more about, or here we are touching more these guys in the deep blue sea, under the surface. So there you could identify all kinds of what Alistair calls sub-functions identified from motion against the user. These do not sound really terribly interesting as user goals, but we need them to realize those user level use cases. So we could use that use case way of thinking even to treat these sub-functions. So it makes sense then to talk about collaborations that stand behind them. This is just to recall the implementation that we had. So we actually discussed this, but not from the perspective, maybe too much from the perspective of what is, well, in a way, yes, what aspect J is capable of preserving. So, to some extent, we can mimic or contain or include those roles that we need to rely upon, like using these inner or not quite inner, but nested elements. They're called formally nested elements, nested classes, nested interfaces. And not much about point cuts that we can do, and here we have this around aspect. And there's this general this is the general aspect, and the specialized aspect, or at the same time a concrete aspect that adds everything that we need to deal properly in aspect J. But that's not what we need to deal at the moment, because we actually played with that with respect to the themes approach. What I propose here is that the elements in themes are actually roles, and roles are not unknown to us. So aspects are based, or aspects are collaborations, or role collaborations of roles. And this thing of dealing with the design at the role level is much older, way too older aspect-oriented programming, way too older than the themes. maybe this notation does not look too attractive. But the exact notation does not, I mean, graphical elements do not matter that much, I guess. Even in object-oriented modeling notations, sometimes cloudy notation like this was used. For example, that would be our building class. And even dashed clouds were used to represent abstract classes. And this was not invented by some I don't know, strange artists. This was legitimate and very much sophisticated at the time, and still making a great one of the basic notations that were considered, or that are in that are essential to creation of UML. That was Grady Butch's notation. Maybe look for this name if you haven't heard. Grady Butch. This maybe incorporate some course on software on software development history, computer science history. So Grady Butch used these things, but these things are not related to Grady, but to somebody else. Trigve. Renskauk. Who's that? Do you know about this? MVC? Model view controller. Trigve Renskauk actually observed, was the first one to observe the model view controller and to give it this name, particular name. There are different interpretations of the model view architectural pattern, of course, now, and maybe it would be worth getting a little bit to the roots again and considering original ideas. And maybe different ideas that came out of that at this time regarding the approach which is called DCI. But let's leave this for some. For the last lecture, maybe we'll get back to DCI to some extent. But anyway. Data context interaction. So Trigve Renskauk is involved in that effort of making a generally applicable, very approach to software modeling or software modeling, software development. But let's consider this diagram. What we have here, nevertheless, how strange this notation is. We see that there are some elements like job offer, product job offer, consumer, and here we have job offer and prerequisite relationship. So we have two separate views on the elements that are related to some kind of a system to help you get job, or to help companies get their new employees. And each job offer actually might be produced or consumed, depending on how you see it, and job offer is often underpinned by some prerequisites that specify what is necessary or what you offer, what are your abilities with respect to that job offer. And two things can be treated separately and then composed into a greater whole, like this. And you can even draw that composition. And this is something that was known some, I don't know, in 80s. It was never this notation. It was never used to its full extent. Maybe some projects, but it's called ORAM. What's right? O. I think it's small. I don't even know whether I'm able to say its full name, but it's object-oriented reuse analysis method.
Role analysis and
Role, not trigger. Role. Role analysis method. Object-oriented role analysis method. Because it's based on roles, but the purpose is reuse. Reuse like this. You can generalize. That was just the first approximation going from the concrete part. This is the concrete part. This is the situation that we have. But we could have a palette of such partial designs that we can compose into greater wholes over a given context. So our given context now, here are job offers. So first thing upstairs up there is the relationship between producer and consumer over an item. So these circles are interfaces, but I don't want to go into details of this notation. It doesn't really matter now. Some of them express even multiplicity. Forget about it. Doesn't matter. So the thing is that, and this is only the structural view. So Triglav in his ORAM method dealt with sequence diagrams as well. So it's a sophisticated method. It's a sophisticated method and comprehensive method most of all. So anyway, but we are looking at this structural way of representing things. So here we have a very generally expressed constellation, and here we are dealing with the item part problem. That's also a generally applicable component, to say so. But these components are not composed as simply as boxes as we can, as we are maybe, as we tend to think of components now. These components are composed in a more sophisticated way, which is actually our aspect-oriented composition. So Triglav and Skau was considering aspect-oriented composition decades before, and you can only imagine how long it took for him to publish the notation. So the ORAM book was published, I think, in 1988 or something like that. Andrew, you confirm that. And the theme approach is something that is from this century. So at least more than 10 years before theme approach. And theme approach is maybe 2004 or something like that, 5. It's not that old. And an interesting thing is that how we are not how we ignore the past. So So the authors of the team approach book do not mention trigger and scope. They do not mention all around. I don't think that the authors took this idea from all around and just didn't want to mention intentionally all around. It's just that the idea was rediscovered. And for the sake of completeness, but this is something that is more clear to us, that modified the stock plan, which extends place and order use case. You might remember from the first lecture, long time. We remind you that this use case actually describes the situation when we are getting out of some products, and because we are placing an order, and in that case we should create a notification to the guys responsible for getting some more products from the stock. Okay, so literally we intrude there from this use case. This use case does not know about this use case, but this use case does know about this one, and it intrudes in a specific so-called extension point. I think I even have this thing there. Yeah, like this. Extension point. And place an order use case and nothing else. And then this modify the stock plan use case hangs on to this, or hangs to this extension point and adds some behavior. So this is asymmetric aspect-oriented modularization. And the implementation, the normal implementation would make us revert this relationship. If we would implement this by this ordering class and so on, we would need to put our code for checking the stock, for modifying the stock plan or the stock plan here. But if we use aspects, we can really be faithful to this use case level specification of design. And maybe we'll get back to that point later, but I would like you to think for a moment about extension points. Extension points, which are introduced explicitly. We talked about the obliviousness of aspects. Obliviousness, that means that aspect obliviousness, not obliviousness of aspects, but what this is. And this break the obliviousness of aspects on the side of the affected code. Maybe it's not stated very clearly. The obliviousness on the side of the affected code. So affected code, the affected code is oblivious of aspects. It's just an expression. It means that the affected code does not know about aspects. The affected code does not know about aspects, so keep this in mind, but you know that, actually. And look at this use case. This use case. I'm going to just check time. We have here an extension point, one extension point stated explicitly. Does this? break this or compromise the obliviousness. I mean, is this, in this case, is this, are we saying that, or exposing that this use case is affected somehow by the extension use case?
I think yes.
Yes? Who thinks yes? Thinks no? Yes? No. Why not?
Because I think that it doesn't have any effect on the executed code in the basic use case. I mean, the fact that it's written underneath the other steps doesn't mean that the code itself is aware of the extension point. So I don't think it breaks the obliviousness.
You said yes? Change
I
your
said
mind?
yes.
But why you said yes?
I said yes because even if I don't know if there exists any other use case that cuts through this use case, it's enough for me to read this use case and I see those extension points and I know that something happens in step 4.
Maybe this checking product availability says something about the nature of
Yes,
how
yes, but also
and
that makes sense what my colleague said. That also makes perfect sense, but I'm still reading this there, so
I wouldn't ask you if the question was simple. The problem is difficult, and you're both right. We are actually exposing that something is gonna happen there. Yeah, we are unhiding this by saying that checking product availability is to be exposed. So you expect something to happen there, and you might expect even the nature of what's going to happen there by the name, from the name, checking product availability. So it would probably have to do something with product availability and so on. So we prepared this for an aspect to get there. But then again, if you pay attention enough to make most general names of your extension points, then you would reduce this breakage or breaking of obliviousness. Yeah. So this is something to consider. Something to consider. We could to mask everything. We could introduce all the extension points that we could imagine, but it would be a combinatorial explosion because we can have extension points with respect to the range of steps. So range of steps can be considered like steps 4 to 7 can be our extension point as well, and we can affect the whole range of steps. And we can imagine even more sophisticated ways. So anyway, it would be it would not be viable for the use case perspective to put all and it wouldn't make actually sense just to mask the situation. So it's something to consider. So if you expose some points by naming some steps, by naming them as to make them extension points, you should probably use more general names that are available there. So not to indicate that what's going to happen there, because even afterwards, in future, you can think of other extensions there at the same points, and those might have a different nature. So should use probably more general names. But it's a different situation a little bit than we have in aspect J, where we do not do this. But that's actually again an opportunity to mention that in AspectJ you can use all Java capabilities, and this includes annotations. So you can annotate in your places in your code, different places in your code, different moments, different methods, and you can. I'm not going to show you those point cuts, but you can find easily annotation-based or annotation-based point cuts in AspectJ. Annotation-based point cuts enable you to address annotated places, and that's kind of a reversal. So you can write an aspect that affects certain the places that are annotated by certain annotations, and then you can use those annotations to pick the places in your affected code. And for some purposes, this seems to be more appropriate, more viable, and acceptable by the people, because people do not like not being aware what messes with their code. And for those purposes, for those cases where people were afraid of what happens to my code and so on, so this was way to apply aspects. And furthermore, it has to do with point cut fragility. It might help you avoid some problems with point cut fragility. So, what we had there, this was still when in the times when object-oriented programming was still high. Year 2000, object-oriented programming is quantification and obliviousness, more related to asymmetric aspect-oriented modularization than to symmetric. And also something you might agree with or not, because quantification means you know what obliviousness means now, but quantification means that you use aspect-oriented programming to address many places. So you use those regular expressions to address many similar methods with your advice code. And this is not that you do always, something that you do always. So you might create aspects that address just few methods, few points, and still they might be worth the effort, because you might reuse them in your further programming efforts, further systems that you develop. So it's not always, but this is very characteristic that to a great extent you will see or encounter aspects that address many places. Maybe it's all spoiled by those classic examples of like logging or monitoring. I need to address many places, many similar places. Yeah. So, actually, there's not much that I have more on this topic. Just to recall, previous cases, we saw that they represent a case of symmetric aspect-oriented modularization, and extended relationship represents asymmetric aspect-oriented modularization. And I hope I have, yes, this statement that aspects can be seen as role collaborations. Or I was much stronger in my claims during the lecture that aspects actually are role collaborations. And this is something to think of when using aspects. That aspects can help us preserve use cases in code. And this approach, DCI, also deals with this trouble of preserving use cases in code. that's something that we struggle with normal object with normal object-oriented code, where use cases are decomposed and lost. And then when we are asked to make some changes come usually from customers, from clients, from users, from the user perspective. From the user perspective, use cases are very tangible, and our technical coding issues are hidden somewhere. So users will talk in use case language, and we must understand what they are talking about and translate that to our technical perspective. And once we have aligned both perspectives, use case perspective, code perspective, it will be for us very easy to come to the places where the change is needed. And it will be for us very easy to decouple use cases. It will be for us easy to compose different systems out of different sets of use cases that we have. And it will be for us more easier to, if we separate this use case perspective from some more technical issues that are below that, like some things in domain are quite stable, and they do not change. Then it will be easier for us to maintain use cases in terms of programming. But maybe that's something that we can get back in the last lecture, or would be appropriate with respect to this DCI approach. But depending on what project topics you have, this might open up some different other possibilities for you to consider. Okay. Any questions?
I do have one question. Can I ask about the notations in Java you mentioned earlier?
Yes.
You introduced it as a way to explicitly state or to explicitly define the extension points for the join points where an aspect is initiated, or where
Yes.
So, but my question is that to me that seems like in a situation like that you wouldn't have to use an aspect in the first place, because if you use this to, for example, denote exact places where a logger should write a message or something, if you do that for a specific number of classes, you go class after class to denote that this is where this is what I want my logger to write a message. You might as well call that logger directly, because until now, for me, aspects were mostly about designing general and general like queries that are potentially infinite, and if you add some functionality that fulfills that criteria, that
yes, exactly. You're right.
But if you use an annotation to specifically choose places in your code where you want to invoke an aspect, it doesn't make sense anymore. You might as well use the actual code. If you do that manually.
Yeah, I understand you very well. Think of, I would like to get back to this. So this is the viewpoint that actually resonates from what you said, and it's purely legitimate. So there's no finite solution for it. It's like an open problem. So you might see it this way or the other way. So I would like you to say that if you have much need for quantification, then the need for obliviousness would be greater. Does it make sense? Yeah. So if you have many places to address higher aspects, many places, then you would it would be very helpful for you if you would not have to mess with that code at all. You don't have to touch it, no annotations, no nothing there. You just address your join points from one place, okay? So, and that's the case of big quantification. The bigger the quantification, the bigger need for obliviousness. And consider this. One extension point, one extension use case. We don't feel it we don't feel that much pressure from making this extension point here exposed. Yeah, but you're right. That was the point. You always have to look for a balance between these two perspectives in using aspects. Okay. Any other question? That was a great observation. Thank you very much. Okay, this is not the last lecture. So we'll have lots of seminars, and we will get back to some of the issues maybe that I presented through the optics of your projects, and maybe I will have something to attach to that. So I don't want to keep you much further. So full block of teaching, but then we'll have less lectures afterwards. Thank you. And, yeah.